Hello, my name is Christopher Fabian and my student ID number is 21055311079, and the lecturer for this subject is Professor Dr. Tjokorda Tirta Nindhia, STMT. And today we're gonna talk about the manufacturing process in metal forming process, chapter 2G until 2I. Okay, let's continue. First of all, what we're gonna talk about on this presentation, first we are able to know about wire forming operations, and then we're gonna learn about tubbing and section operations, and the last one we're gonna know about non-sheet forming operations. First of all, we're gonna talk about wire forming. Wire forming is component made from bent and formed wire are useful when an open configuration, such as those used in baskets or fan or machine guards, is required. Bending methods used for sheet metal, rod, tube, and other cross-section are normally also applicable when the workpiece material is wire. Other operations that can be performed on wire including swaging, cold heading, resistant, arc or gas welding, and threading. And this is the example of wire forming from swaging process. So you can workpiece come into the anvils, and then the anvils gonna start doing their things into workpiece and making into wire. Maybe it can be smaller because of the swaging is reduce the radius of the wire. I have a video here about manual forming of wire parts. Wire can be bent with hand power, bending brakes, kick presses, or various fixtures with hinge and or provided elements, since force are required low. Bending tools similar to tube benders can be used. Hand bending may be applicable when quantity is small. So here's the video. Now we're gonna enter into G1B about wireforming power presses and special machines. All bending operations performed by presses, press brakes, force slide machines, and other component can be performed like we have talked about on the before video, on the previous video, with suitable tooling on wire workpiece. Additionally, wire is formed into springs of various shapes. You can see on springs. In high production situation, the wire is fed from continuous coil and is formed and cut off automatically. So on this one I have a example from spring coil winding. Is just making a wind like curl. So it start from here and then gonna be pulled to there, and then it's gonna be winding. And there is press brake, but it's wire like the previous on the sheet metal operations. Forming in four slides machine. It is applicable to parts to form from wire or sheet metal strip. Four slides machine have a forming area with four presses slides set 90 degrees apart and driven by cams. Cams is on here, so it drives the material object. There is also center post that can be shaped to facilitate forming. Tools on the slide are designed to blank, pierce, notch, bend, form, emboss, and cut off the wire or strip as it progresses through the machine. So the machine from here, it's gonna be straightened by the rolls and gonna be eaten, and then the press boulder gonna press ram. It's on the first section, and then go into this is the center, and then there is right slide, left slide, and rear slide and front slide. It's gonna be pushed into the corner and gonna be pulled by here, and then the stripper cam, and it's gonna be the end, and then the cutoff, and then gonna be go down to the blank. I mean to the final part, like the exit. We have the video here. Spring forming. A spring is a device that changes its shapes in response to an external force, returning to its original shape when the force is removed. The energy expended in deforming the spring is stored in it and can be recovered when the spring returns into its original shape. Generally, the amount of the shape change is directly related to the amount of force exerted. If it's too large, a force is applied, however, the spring will permanently deform and never return to original shape. Remember that? So this is the one of how to make spring. So the wire gonna be get rolled, gonna be pulled to there, and gonna be pushed by dice or pitch tools here, and gonna be continue. It's like you making winding. Torx head rolling of wire is used to change the cross-section of round wire, rectangulars, square, and special shapes can be imparted to the wire by passing through opposed rollers arranged so that the opening between them is the shape of the cross-section desired. So you can see here, this is the cross-section of round wire. So when you want to this shape, you're gonna put the position of the roller is gonna be like this shape. So it's gonna be pushed through there, and this is the final part of the head. Now we're gonna talk about tubbing and section operations. H1. Tub spinning. Tubs can be spun to provide tapers or flange by using metal spinning methods similar to those used in spinning sheet metal. Two different methods can be employed: forward tub spinning and backward tub spinning. As you can see here, if the forward, this one, it's gonna be pushed by the punch slowly, and there is mandrel, and the work part is the gray one. It's gonna be pushed, and the material flow it's gonna go forward. The difference between the backward, it's gonna be push, and the material flow gonna be go backwards. That's just the difference. Tub and section bending. H2A. Draw bending is used bending tubbing, section, and bars. Like we talked before, the workpiece is held against a bending formed by a shaped clamp. As the bending form and the clamp rotate together, the workpiece is pulled or drawn around the form and against the pressure die, whose form also matches the cross-section of the workpiece. The pressure die can be either stationary or movable along the longitudinal axis. So this is the rotatable arm that can be movable, and the supernatural of mandrel is used by here, and then gonna be push, and this is the axis can be bent and moved to die, and then this is you can see here it can be moved together to the tubular workpiece. So now let's talk about compression bending. It's similar to draw bending, but the forming block and clamp do not rotate. Instead, the pressure die is replaced by a wiper shoe of or fitted roller which moves along the periphery of the stationary bending form, causing progressive bending of the workpiece. No internal mandrel is used except the outer surface. The tubbing can be subjected to some compressive stress. The operation is normally manually powered. So the compression here, it's gonna be clamp position. The clamp here, it's gonna be hold, and the bend position is gonna be go to upwards, and it's gonna be bended through a rolling. And this is called compression bending. Clamp and press bending is a method applicable to tubbing, bar, and other sections. It is a method applicable to tubbing, bar, and other sections around the forming block as the press ram descends. Wiping action, the wing dies control the flow of the metal and provides a compression bend. The length of the press stroke determines the angle of the bend. Typically, hydraulic presses in which the press stroke can be stopped at any point are employed. No mandrel is used. So it's gonna be fit into here, and the ram gonna be pushed to make the bending, and the counter dice here or the press, like we have learned about the press bending, and it's gonna be pushed by the ram. The counter die is stationary or not movable, and it's gonna be stopped until the workpiece is bended. Stretch bending. It's applicable with variations for bending of tubbing and other sections. The workpiece is stretched longitudinally to the yield point and then is wrapped around a bending die or form. A mandrel is not needed, but the method is not rapid. It is applicable to bends of non-uniform radius. More than one low angle bend can be made in one operation. The end of the workpiece may have to be trimmed off after the bending operations because the distortion from the gripping jaws that provide the stretching tension. So the jaws is gonna be held on the clamp here and the clamp here, and the stationary die here is hold, and then the clamp and clamp which connected to gripping jaws is gonna be pulled to the stationary form or die, and it's gonna be stretched. And the final part here and here, it's gonna be a bit broken, but we can do the same thing by trimming. Wrinkle bending. Wrinkle bending is a method for bending large, heavy wall, tubbing, or pipe. It is applicable to fill the conditions since it can be done by hand with no special tooling. One side of the tubbing is heated locally by gas or torch to the point where the tubbing wall softens. A compressive force is applicable to the pipe, causing the soft area to wrinkle and the tubbing of shorten of that area. Production is shallow bend. So we can say here it's gonna be heated and it's gonna be heated on the inner part, and the pressure here gonna hold and the clamp die is gonna be pulled. This is bend die, it keeps moving, and the wrinkle zone here and here. So if we see from, wait, I'm gonna take my pen. If we see here, this is the normal one. If we talk about wrinkle bending, it's gonna be like this. It's gonna be wrinkle, 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 and then continue. It's gonna be like that. Roll bending. Roll bending is a means of putting gentle bends into tubbing pipe bars, rolled or extruded shapes, plates, and sheets. Usually, three parallel rollers are provided in a triangular arrangement with the lower two being mechanically driven, and the third place above here is the third place is above, and the between them at height can be varied depending on the diameter or thickness on the workpiece and desired degree of curvature. This upper roll is usually not driven; it's just movable. So the rotation is gonna be caused by the first roll and the last roll. So the direction is gonna be come to here, and it's gonna be pulled there, and the movable it can be pushed to the bottom, like you can go lower and higher depend on the bends that you want. And the rotation between this and this is gonna be on different, like this is the clockwise and this is the counterclockwise. Roll extrusion bending. This method is used for large, heavy walled pipe. One wall of the pipe is swayed by from the inside, causing it to elongate and the pipe to bend. Pipes of 5 to 12 inch or 125 to 300 millimeters can be bent with this method to a minimum bend or radius of 3 times the diameter. Successive bends is in different lengths can be made with this method, but a strict section must be allowed between bends. So we can see here, this is the roll extrusion. If we talk about extrusion, it's gonna be push, like, and then you're gonna be pulled through the hole. So it's gonna be like this. The previous, like, if we imagine the diameter is bigger than the final here, so it's gonna be forced to go through this hole. Bulging mechanical. Bulging is an operation that expands a portion of tubular or cylindrical part. When done mechanically, a segmented die or with segmented hold together by springs is inserted into the tubular part. During the presto, a tapered punch push the segment apart and they in turn push out the walls of the workpiece. The process produces a pattern expansion flat on the rounded tubbing because of open space between the die segment when they are expanded. So the step 1 is here. We can see here the upper tool is gonna be like the die, and the die here is gonna be hold, and then it's gonna be pushed so the wall of the bulging can be started. And here sheet here gonna be pushed to the bulge, so it's gonna be double bulge. So the wall inside is gonna be pushed by mandrel here. That's all. Bulging hydraulic. Expand tubbing pipe or cylindrical part by applying internal force with a pressurized liquid of an elastomer. Elastomer is low durometer rubber or polyurethane. The workpiece is contained by a die that is split so that the bulge part can be removed after the operation. With direct hydraulic forming, the tubbing is filled with water, sealed at the end, and placed into the die and pressurized. Water pressure forces the tubbing walls around to conform to the shape of the external die. So we can see here, this is the hydraulic bulging, the example one, and the shape is gonna be put into the die, and the punch gonna be pushed through the tubular workpiece, and we have like elastomer here or the water one. Because the water pressure is gonna be filled to the cavity of the dies, so the final part is gonna be like this. Remember, we use like elastomer forming member or water. Non-sheet forming operation, shearing of bars and other non-flat shapes. Alligator shears are commonly used for shearing bars and other section to length. Guillotine shears vertical presses permanently fitted with short shear blades are another alternative in shops where there is much bar shearing. The blades of the guillotine shears may be notched or grooved to aid in maintaining the location of the workpiece during cutting. So it's gonna be similar to simple shearing operation is performed. So the workpiece is gonna be held by the pad, and the upper blade is gonna be cut. It's the lower knife, and it's gonna be cut it into this, and this part is gonna be dropped. Called heading. We remember about heading in the previous video. Heading is making the head of the, like you can say it's nails or everything that has head that can be connected to the tool. Cold heading is a process for upsetting, enlarging, and shaping the end of the rod, wire, or bar. It is commonly used the production of bolts, rivets, nails, and screws. One or more blows of heading tool against the end of the rod or bar displace some portion to change its shape and enlarge its diameter. Material is usually fed from the coil stock. The material upset is that portion of the workpiece that extends from a stationary die. A series of blows with different punch may be required in order to produce the desired head shape. So we can see here, this is the die. It has shape like here and here, and this is the work part. It's gonna be hold together, and the punch here is gonna push, push, push until the head become like this. The variety of shapes from cold heading process can be a lot, but this is just the example one. Thread rolling. Screw threads are made with large number of different methods involving both machining, like cutting and forming processes. Cutting methods include the use of hand-operated taps and dies for internal and external threading, and machines for single-point screw thread cutting. thread cutting die heads, and thread milling and thread grinding. Forming methods include rolling of external threads and cold forming of internal threads. So here we can see the previous part is like just this, and gonna be push and the die here gonna be working on the workpiece to make the thread rolling. So I have a video here, we can see like I told before, it has, like we can see here, it's the workpiece that before like it doesn't have like the thread rolling. After the thread rolling, it's gonna be have like pattern. It is oil to make it's not like that, because when metal meets with metal and it's like, I don't know how to say this, it's gonna be causing a fire, so oil or water is needed. Okay, that's the video. Impact or cold extraction forms a part of some length by plastic flow of metal under compressive stress into an opening of limited size. The process is normally referred to as impact extrusion when non-ferrous metal are involved, and cold extrusion when the workpiece is ferrous. A blank is placed in the die and a punch put pressure on the blank, causing metal to flow in the desired direction. The press used can be either mechanically or hydraulic. There are three varieties of the process: forward extraction, backward extraction, and combined extraction. We're gonna talk about backward extraction. Like we talked before, metal blank is placed in the die and the metal is compressed by the punch and forced to flow backwards. So the blank here and stripper plate gonna be put together, and after the push of the punch it's gonna be go backwards. Remember on the previous one, like the on the wire one, it's gonna be go backward. The side of wall thickness of the part depends of the clearance between the punch and the dies. Forward extraction. In this process, sometimes called the hooker process, the workpiece metal flows forward or normally downward through an orifice rather than upward around the punch. A close fit between the upper portion of the punch and the die prevents the upward flow. Hollow parts can be produced by providing clearance between lower portion of the punch and the die orifice. So we can see here it's gonna be push this one, and it's gonna be, and here is the die, it's gonna be push, and this is the black one is the workpiece, it's gonna be push and it's gonna go forward. combined extraction is about forward and backward impact extraction at the same time. And one part, the backward extraction can have a different solid or hollow shape and the shape than the forward extraction, because you can see here it's pushed by the punch and the flow is going backwards. Typical parts of a center of range with different cross sectional shapes. So we can see here we have like hollow, and we can have the clearance between the punch and the dice. So when the punch is pushing, it's gonna go backwards and it's gonna be go forwards. That's all, and that's the end of the video. Hope you guys remember that thing, and I can explain you later about something more. So see you later, guys.